Alright, so you should have your toolkits out because we're going to add 2 new parent graphs to our toolkits today. We're going to apply what we learned about transformations to investigate 2 new parent graphs that are going to be a sleeping parabola and a circle. And so we'll talk about what those look like in just a second. We're also going to define the meaning of a non-function. So we've spent a lot of time in this class talking about what a function is, and today we're going to see that the sleeping parabola and circles are not functions. So let's start, we'll talk about the sleeping parabola first. So we'll investigate the function x equals y squared. Now this looks a little weird because it's not y equals something, which is how we're normally used to seeing equations. It's actually x equals y squared. So I want to see what this looks like, but in order to plug it into my calculator, it has to be in y equals form, not x equals form. So in order to do that, I'm going to solve it. And so I'll take the square root of both sides, remembering that when I take the square root of both sides, I have both the positive square root of x and the negative square root of x. So in your calculator, please plug in the y equals positive square root of x and y equals negative square root of x. So go ahead and pause the video so you can plug those into your calculator. Then go ahead and click on your graph button on the top right, and you should see that the positive x squared gives us that square root function that's purple here on my graph. So if you see this purple part, that's the positive. And then we also have the negative part, which is on the bottom here. So we investigated already the square root function. So this is just 2 of them on top of each other. Then we call this a sleeping parabola because it's tilted. It's a parabola, like it would open up, but it's tilted on its side. So this can either be opening up to the right or it can be opening up to the left, depending on if it's flipped or not. And the general form of the sleeping parabola equation looks a lot like the general form of a regular parabola, except x and y are switched on our axes. Okay? And the other difference is that normally it's x minus h plus k. Now if you look at this one, it's backwards. Okay? So the horizontal stretch is still that b value that comes out front. Okay? So that'll either stretch our graph out or it'll compress it in towards the y-axis. That vertical shift k value, the y vertical shift of our vertex, comes inside the parentheses this time, the up and down shift. And the horizontal shift comes after that squared this time. Okay, so our vertex is still at h comma k. We'll talk about that a little bit when we fill in our toolkits, but our h and our k are in different places, so you have to be really careful about that. So go ahead and take out your toolkit, and on the top of the next open box you have, write sleeping parabola, because that's what we're going to call this one. Go ahead and fill in the parent equation being x equals y squared, and then write in the general equation of this line that we just talked about. The next thing we're going to do is we're going to fill in this table, and you'll notice that at the point x equals -1, our function is undefined. And the reason for that is because if you look here at x, there's no squared number, there's no y squared here, that's going to give me a negative x value. So every negative number is undefined, which you can see in this graph. Anything to the left of 0, we don't have any values for. And obviously that'll change if we do a horizontal shift of our vertex, but we'll talk about that later on. So then fill in the rest of your points in your graph and go ahead and draw your sleeping parabola. The properties of this is that it's not a function, and if you see, it does not pass the vertical line test. If I drew a vertical line through this thing, it would cross this equation 2 times. There's also no asymptotes, so these arrows on the end tell me that I'm going on forever in the positive and negative direction vertically, and we don't have an asymptote at 0 because we just have a point there. It's not a line that approaches forever. It's just a point. So there's no asymptotes in this graph. And if you look at our domain, in this particular graph, h is the furthest left point on the graph, and it goes on for infinity to the right. If we flipped this graph, it would go on towards negative infinity, and it would have the highest x value it would have would be at its h point. And that is the x coordinate of the vertex. So that makes sense for our domain. Remember, domain talks about how far in the x direction we go. Range on this one is negative infinity to positive infinity. It doesn't matter if we're flipped or not. This graph is going to go on forever vertically. And so the vertex of our equation is described by hk, which you can see down here. And I actually did a little erasing, and I put another form of the general equation. So when we type this into our calculator, we'll always put this y equals form. So make sure you have that on there as well. I still have the x equals form, but I also want to make sure you have that y equals form. So make sure those are both on there. Pause the video to finish any other notes you need on this part of your toolkit, and then go ahead and go on. The next thing we're going to do is investigate x squared plus y squared equals 25. So that's our new parent function, and it might look a little weird to you, but we'll talk about what it does. So again, when we plug this into our calculator, we've got to solve it for y. So I'm going to subtract x squared on both sides, like I did right here, and then I'm going to square root both sides, remembering that I have both a positive square root and a negative square root. Okay, so go ahead and pause the video and plug those both into your calculator. And now you should hit the graph button, and I didn't color code it with the positive and negative this time, but you should have a graph that looks like a circle, just like the one here. The general form of this equation is 25 equals x minus h squared plus y minus k squared. And we'll talk a little bit about this 25 right here, but the 25 actually shows me what the radius of my circle is. So right now, the radius of the circle that you should be looking at on your calculator is 5. If you look here, there's a distance of 5 from my vertex all the way around. And the vertex is shown by a horizontal shift h and a vertical shift k. Okay, and it's always a minus on both of those. So now both of these are going to be backwards, and I'll show you a little bit what I mean. So go ahead, in your toolkit, we're going to call this one a circle because that's what it is. So go ahead and write circle on the top. The parent equation that I'm graphing is x squared plus y squared equals 25. And the general equation is x minus h squared plus y minus h squared equals 25. We're going to fill in our table and our graph, and I just put a bunch of different values in, keeping in mind that a lot of these give me both a positive and a negative answer. And then go ahead and graph your circle on the x and y axis with a radius of 5. The properties of a circle is that it's not a function, again, and there are no asymptotes, which both should be pretty obvious to you by looking at that picture. And the domain and range are the same. I go from the negative radius to the positive radius. So whatever that radius of my circle is, those are the values that my x stays between and the values that my y stays between. Okay? And the description of h comma k is the center of the circle. Notice that I also added again the y equals form of the general equation. So make sure you have both the center of the circle written down here and the y equals form of your equation up there. Now I talked about that r value a little bit. I'm going to ask you to do something on the next page, so listen carefully. This 25 is actually r squared, my radius squared. So that would mean that to figure out what my radius of my circle is, I take the square root of that number. Okay, so if my number is 25, I take the square root of that, and my radius all the way around the circle is going to be 5. Now, if I have 16 instead of 25, so x squared plus y squared equals 16, my radius is going to be 4 all the way around. So I take that number and take the square root of it. Now, obviously, if my center has moved, it's not going to be a radius around the origin like this. It'll be a radius around whatever my new center is. And we'll do some examples like that in class. So on the back of your toolkit, go ahead and answer this question. So I want you to answer, what is the radius and center of the circle x minus 4 squared plus y plus 2 squared equals 100? Keeping in mind what we just talked about with the radius, and look at your general form of your equation to find your vertex. It's not going to be intuitive, okay, which way left and right and up and down that it moves. So make sure you're paying close attention to what your general form looks like and what that h and k would have to be. And we'll talk about that first thing in class on Friday. The last thing I want to mention really quick before we move on is what a non-function is. So it's got to have more than one output for each input, which means at the point, for example, x equals 2, I might have 2 y values that goes to. Okay? So it's the opposite of a function, basically. It does not pass the vertical line test. So I should be able to, on a function, draw a vertical line through any point of that graph and only cross the graph once. Okay, so if I draw a vertical line and I cross through my my graph 2 times or 3 times or 4 times, it's not a function. So if you look at your sleeping parabola and your circle, they are both non-functions. They're still going to be our parent graphs, and they're still going to be important to us as we move them around to do transformations, but they are not functions.